Hello students, welcome to Purnang. So today how you tried this question, see which concept did you use to try it. So of course the first step is to determine the indeterminate form. So which indeterminate form is it? So it's infinity minus infinity in numerator upon infinity. So the problem is infinity minus infinity. So it's a mix of indeterminate form. In any case, you can't of course evaluate it directly. We have to use a method. Which method is the key? Okay, so see, I will say limit as x approaches infinity ln x by greatest integer of x minus 1. That's the first thing. Okay, I just wrote it as greatest integer x upon greatest integer x. Fine. So now what? See, now for this, see, we know at least for greatest integer function, we have a ready-made condition for Sandwich theorem. So what is Sandwich theorem? I will just discuss it just a minute. I will say, okay, we know that greatest integer of x is always greater than x minus 1 and less than equal to x. Okay, so now let us discuss the Sandwich theorem. I took that name, so I will be using it here. So Sandwich theorem, what does it say? It says that, okay, if you have a function which is sandwiched between two functions. So if fx lie between g of x and h of x and limit as x approaches a, g of x is equal to limit as x approaches a, h of x. So both the extreme functions gx and hx, if they approaches to the same value as x approaches a, let's say is equal to L. So this implies limit of f of x as x approaches a is also L here. So that's the Sandwich theorem. Okay. So now see one more thing here. As x approaches infinity, so x is a positive number. So greatest integer x, x minus 1 and x, they are all going to be a positive number. Okay, so now coming back to this form, so I will say since greatest integer x lie between x minus 1 and x, so it's reciprocal. So 1 upon greatest integer of x. Won't that be greater than equal to 1 by x? The sides will interchange their position. Okay, like the extreme left will now appear in the extreme right, and extreme right in inequality will now appear in the extreme left. Now multiplying all three sides of this inequality by ln x. So now you have that condition. So ln x. So the expression is ln x upon greatest integer of x, whose limit we have to evaluate. Now we know it is a function fx which lie between g of x and h of x. Okay, and we have to evaluate its value as x approaches infinity. Bachcho. Okay, so what did I tell you according to Sandwich theorem? That if the limiting value of the left extreme and the right extreme function is come out to be the same as x approaches infinity, the same value this function will also take as x approaches infinity. So let's evaluate it. So limit this, what about this? So I'll be again using this infinity by infinity form. So we'll be using what? We'll be using here L'Hospital rule. So let's apply it. So differentiating numerator, you get 1 by x upon 1 as x approaches 0, that goes to 0. Here again, it's infinity by infinity form again. So again, let's apply L'Hospital rule. So it's again 1 by x upon 1. So that again goes to 0. So as I said, according to Sandwich theorem, if both the extreme function as x approaches a approaches to the same limit, then the function lying between these two will also approach the same limit. Okay, so this approaches to 0. So the answer is, of course, that's the one part. So this approaches 0. So the answer is 0 minus 1, which is minus 1. So that was a limit, a question of limit based on Sandwich theorem, a simple application of Sandwich theorem in limits, bachcho.